Hi, welcome to another video on differential equations. We're going to be talking about Laplace transformation on a special function. There are a lot of special functions, and this is one of them. Okay, so if we look at this, we have the Laplace of e to the at times a function of t. Well, like we said, we can't really do multiplication, right? So what's going to happen is a little special. So what's really going to happen is like this e to the at is going to be absorbed into this f of t function, okay? And we basically just let it chill in there, let it relax until we need it again. Then we have the Laplace of the function f of t. However, we have to take into consideration about this e to the at that we just absorbed into that function of t. So when we get our function of s, every time we see an s, well, that's going to change and go to a function s minus a. So every time we see an s when we're done, that s is going to turn into s minus a. Basically to take into consideration of this e to the at. Because the Laplace of this e to the at was also Laplace, okay? So here's an example. Usually it'll give you either the regular Laplace or the inverse Laplace, and that's why it tells you to find f of s or f of t. So if we were to Laplace this e to the power of 2t times t minus 1 quantity squared, well, like usual, we don't really know how to deal with this yet. So what we'll do is we'll expand it, all right? And if we expand it, we get this Laplace of e to the 2t times t squared minus 2t plus 1, right? Okay, great. So now, here's where the absorption comes in. We're just going to let this e to the 2t be absorbed into this function. And now we have t, we have the Laplace of t squared minus the Laplace of 2t, or just t. You can put that constant in the front, plus the Laplace of 1. All right, so the Laplace of t squared, that's going to be 2 over s cubed minus the Laplace of that t is going to be 1 over s squared, but we have this 2, so we'll put that 2 over there on top, okay? Plus the Laplace of 1 is 1 over s. Great. But we're not done, because we absorbed the e to the 2t. We have to take into consideration of that. And so like we said here, s will go to s minus a. In this case, our a is 2. So every time we see an s, that's going to go to s minus 2. So we're going to change all our s's to s minus 2's, okay? So we'll have 2 over s minus 2 quantity cubed minus 2 over s minus 2 quantity squared plus 1 over s minus 2 okay. And so if you couldn't see that, I'll write it up here. Okay, so like I said, all our s's will turn into s minus 2's. All right, so that's going to be 2 over s minus 1 quantity cubed minus 2 over s minus 1. Oh my gosh, it's s minus 2. Okay, so 2 over s minus 2 quantity cubed minus 2 over s minus 2 quantity squared plus 1 over s minus 2. And so this would be the Laplace of that function f of t. So this is our capital F of s. So basically, what was new is we dealt with this special case. And this e to the 2t was absorbed into that. We basically went along and we took our Laplace of whatever that is as usual. And then we got our s's. However, we weren't going to stop there because of this e to the 2t that we didn't deal with. All the s's will turn into s minus 2's. And then we substituted s minus 2 for all the s's. And that's the special function. Great. So let's look at another one. I'm going to keep that up there as a reminder as what we're supposed to do. So if I have this Laplace of e to the t cosine squared 3t. Oh my gosh, I've never seen that before. Have you seen that before? I don't know, I've never seen it. All right, so how do we deal with that? Cosine squared 3t. Well, what we're going to do is remember this, that cosine 2t is equal to t, not that one. Actually, yeah, we could write that one down too. Cosine 2 minus 1. And we can also recall cosine of cosine squared t is equal to 1 plus cosine 2t over 2. Well, our argument isn't 2 like it is here. It's actually a 3. So what we could do is we can make this argument 3. And that would be 1 plus cosine of 6t. Over 2, of course. And now we have cosine squared 3t. Looks like we have cosine squared 3t. Perfect. So, what I'm going to do is use this one. Cosine 6t over 2. All right. And so guess what's going to happen to this e to the t? Well, it's going to be absorbed. I don't know how else to put it. That's how I remembered it. All right, you can go in there, e to the t. Now we have, well, I can factor out a 1/2 as well. So I'm going to have that 1/2 out there because it's a constant. Now I'm going to Laplace 1 plus the Laplace of, what do we have? Cosine 6t. Great. Well, these we know, of course. We have 1/2 times 1 over s plus cosine of 6t. That's going to be s over s squared plus 36, right? Because this is our k, and here we're supposed to square it. Okay? And do you think we're done? If you said yes, try again. No, we're not done yet because of that e to the power of t. Well, that was absorbed into this. Now we have to take that into consideration. All right, so our s's will go to what? S, maybe s minus 1. Definitely s minus 1. This was our 1. Our a's are 1, right? So s minus 1. Okay, great. So every time I see an s, I'm going to replace it with s minus 1. So 1 over s minus 1 plus s over s minus 1 squared plus 36. Oh, that s also should get a s minus 1. And that's all multiplied by what this 1/2. Right? Great. Looking for a juicy problem. And then, well, after we've replaced our s's with s minus 1, that will be our answer. Okay? Maybe leave that up there for a reminder. Okay, so if we had this, we would have this process. Okay. However, if we had the inverse, we would expect something different. So we'd have the inverse Laplace of f s minus a. Well, this s minus a tells me that there was an e function that was absorbed. So that tells me I have an e to the at. So once we pull that e to the at, once we pull that a out, we're left with the inverse Laplace of this capital F of s. And that the inverse Laplace of this capital F of the function s was simply the function f of t. So this would be going from t's to s's, and this is from s's to t's, and that's how you know you probably did it right. All right, so the inverse Laplace of f of s minus a tells me that there's a e to the at, whatever that might be in there. So we're gonna have to pull it out. Okay, so we pulled it out, and now we're left with this inverse Laplace of f of s. Okay, and inverse Laplace of the f of s was our function f of t. So we get this. Okay. Well, that's new. I wonder what a problem will look like. All right, so we're going to have to find the inverse Laplace of this function, 1 over s squared plus 2s plus 5. Now this takes a lot of observation. Well, since we're talking about the special function, I can't really see a function in that. So I'm going to make it so that I could see and I'm going to manipulate the problem. So I went from s squared plus 2s plus 5 in the denominator to s squared plus 2s plus 1 plus 4. Well, if I were to combine those, I would still get 5. And now this basically allows me to get this 1 over s minus 1 quantity squared, s plus 1 quantity squared plus 4. Because now we're only talking about this, right? So that factors to that, plus 4. Well, I know now that my e function is in here somewhere. Okay? And now that tells me I have an e to the minus 1 t. So now I have e to the minus t out here. I'm going to inverse Laplace this 1 over. Now when you take the e to the negative t out, you're left with only s's, with just a single s. Okay? So we took out the e to the negative t out of that s plus 1. Now we're left with s to the s squared, just by itself. Okay? And now that's e to the negative t. The Laplace of this is going to be a sine. However, this 4 is actually k squared, which is 2 squared. And we also have to multiply by 2 and divide by 2. So we multiply by 1/2. So we can divide by 2 over there. So this is actually 2t. So if we think back to what the inverse of that was, sine of kt, well, our k, like we said, was 2. So that's why that k is 2. And originally it's k over s squared plus k squared. Well, we have to take into consideration of that 2. And we multiply by 1/2. Okay? So there's our answer. So here, basically s plus 1 will go to s, if you want to think about it like that. Okay? And trust me, there's going to be a lot of manipulating something like this, just to make it to where you're able to Laplace something, or yeah, basically. So maybe let's take a look at another one. You will have to, or we can get into, okay, yeah, one more that we'll have to manipulate. Okay, so the inverse Laplace of s plus 1 quantity squared over s plus 2 quantity squared. Quantity quadrupled, actually. All right, so can't really do anything here because these aren't the same, so that doesn't mean I get an e to the at anywhere. So they have to be the same in order for you to extract an e to the at. So how would I make it the same? Well, s plus 1 squared can also be written as s plus 2 minus 1, sorry. Quantity squared. Okay? And that equals s plus 2 minus 2s plus 2 plus 1. Okay? Perfect. So we just manipulated this numerator. And this is where manipulating is totally fine. Usually being a manipulator is bad. But when we're talking about this special function, it's great. Okay, so that made it a lot easier to see what our e to the at is going to be. So if we extract an e to the at, well, our a is going to be a negative 2, so e to the power negative 2t, and we Laplace all these s plus 2's will now turn into s's, right? So we have s squared minus 2s plus 1 divided by s to the 4th power. Well, this is now something we've seen before. If we split it all up, put s squared over s over 4 minus 2s over s4 plus 1 over s to the 4th, we're going to get e to the negative t Laplace 1 over s squared minus 2 over s cubed plus 1 over s4. Okay? I'm going to get e to the negative 2t times t minus t squared plus 1/6 t cubed. All right? So if you don't know what happened here, well, this is just factorial 1 factorial, and that's s to the 1 plus 1 power, so that's just t. Well, this here is n factorial, right? So we'll have to divide by 2. That gets rid of our 2. And here it's going to be 3 factorial, so that means we have to divide by 1/6, right? Since we don't have this 3 factorial, since we don't have it, we'll have to multiply. Multiply by 1/6, and so that's where that 1/6 comes from. All right, and so this is how you solve that. Perfect. Manipulating equations. All right, thank you. I hope you understood this special function for Laplace, and see you again.